Okay, we're looking at exercise 4D from the second year mechanics. That's a mechanics textbook. So we're looking at moments and the centre of mass. So we're going to have problems where the centre of mass is not at the centre of the rod. So the first thing it tells us is it's a non-uniform rod. So that means that the centre of mass will not be working through the centre of the rod. We're given the length, we're given the weight of the actual rod, so that's worth noting. It's the weight rather than the mass. And we've got two supports, A and B, and we are given that the centre of mass is 2.4 metres from the end A. Okay, so first thing we want to do is get a quick sketch of that. So I've got my non-uniform rod. I've got support. So it says that the rod is AB, and then the supports themselves are at A and B. So the supports are at the very ends of the rods. Given that the centre of mass is 2.4 metres from A, and remember I'm given the weight, so I don't need to multiply that by G. That is 6 newtons. So that's 2.4 metres. Find the reaction at the two supports. Well, I know that, so there's going to be a reaction at A and a reaction at B, and there's no other masses or anything on this rod, so they're the only three forces. So I know that the reaction at A and the reaction at B added together must equal 6 newtons. So that's from resolving vertically. So the reaction at A plus the reaction at B must add up to 6. So if I can find one of them, it's going to be quite straightforward to find the other one. So I'm going to find one of them by taking moments. I've got 3 places I guess I could take moments. I could take moments at A, I could take moments at B, or I could take moments about the centre of mass. Of those options, taking moments about the centre of mass would be the worst, because I would still have 2 unknown forces that I would have to include. So I think taking moments about A or B would be equally sensible. So let's take moments about A. So if I take moments about A, I don't need to worry about the reaction at A. So when I'm taking moments, it's the force times the perpendicular distance. So the perpendicular distance from A of this force here is 0. So that is not going to figure in my calculations. It's in equilibrium. So the anti-clockwise moments must equal the clockwise moments. So I've got 2 moments. I've got the 6 newtons, which is 2.4 meters away from A, and that's going to be trying to rotate the rod clockwise. And then I've also got the reaction at B, which is going to be trying to rotate the rod anti-clockwise, and it's not rotating, so they must equal each other. So I know that the total length of the rod, so it's reaction at B, and they tell me that the rod is 4 meters. The moment is force times distance. So that then works out to be quite a straightforward calculation. So 6 times 2.4 is 14.4. The units there would be newton meters, and that is 4 times the reaction at B. So if I divide that by 4, I get that the reaction at B is 3.6 newtons, and then that would mean, going back to this statement here, if I do 6, take away 3.6, I get 2.4 newtons to the reaction at A. Okay, and we will just have if I was in an exam, I could also take moments about B and just confirm that does give me 2.4 newtons for the reaction at A. I just wanted to triple check. But yeah, I think we agreed with their answers. That's good.